Hello children, let us understand the difference between the distance and displacement. To start with, let us assume a particle which starts from the point A and following this path, it comes to the point B. Now distance will be the length of the actual path that is taken from the point A to the point B by the particle. But when it comes to displacement, it will be the shortest distance between the 2 points A and B. That will be the straight line joining the points A and B. So it will be like this. We can say that distance is this point, this path length. This is the distance, actual path length, actual path length, and displacement is this straight line between the 2 points AB. So displacement is the shortest distance between the 2 points A and B. Now I have noted down the difference between the two, distance and displacement. First point is distance is the length of the actual path taken by the particle between the 2 points. Displacement is the shortest distance between the 2 points. Second, distance depends on the path. It is very clear from this diagram that distance depends upon the path. The path taken by the particle between the points A and B. And displacement doesn't depend upon the path. It simply depends upon the initial and the final position. Distance has only magnitude, so it is a scalar quantity, but displacement, as is clear from the diagram, has magnitude as well as direction. Magnitude is the length of the straight line joining the initial and the final position, and direction is from the initial to the final position. Now distances add like numbers, obviously because they are scalar quantities, so distances add like numbers, and displacements add according to the triangle law of vector addition, because obviously they are vector quantities. Now let us have a few examples to explain this distance and displacement. Let us take a circular path. This is the circular path, and let us say a particle starts from point A, travels along the periphery of the circle, and moves to the diametrically opposite point B. And the radius of the circle is, say, 7 meters. Now, what is distance and what is displacement in this case? Distance will be the length of this path, A, C, D, E, B. Distance will be half the periphery or half the circumference of the circle. Circumference. We can write it half times 2 pi r, or this is half and 2 gets cancelled out. This is 22 over 7 times 7, or 22 meters. Displacement. When the particle is at point B, it started from point A. So what will be the displacement? Displacement will be the straight line joining the point A to the point B, the length of this straight line. This will be the displacement. So what will be the length? This will be the length of the diameter of the circle, diameter, or this will be 2r, or we can say 2 times 7, that is 14 meter. Coming to the next example. Distance and displacement are very important quantities because when you study average speed and average velocity, you will be using these two quantities. When there will be average speed, you will be talking about only distance, and when you will be dealing with average velocity, you will be discussing or you will be concerned about the displacement only. Now, suppose a particle moves in a, say, a rectangular path. Say the particle starts from point A. This is the side of the rectangle A, B, C, D. This is 4 meters, say. This is 3 meter. Suppose the particle starts from A, moves to B, and then moves to point C. What is the distance and what is the displacement? Distance is clearly the length of the actual path. That will be AB plus BC, or 4 plus 3, that is 7 meter. And when it comes to displacement, we simply join the initial and the final points, A and C. So this is our displacement. This is displacement. We can use Pythagoras theorem for this. Displacement will be square root of AB square plus BC square. This will be square root of AB square is 4 square plus 3 square. You will get 5 meters. Now say the particle would have started from point A and it comes back to the point A. Then what would have been the distance and displacement? In that case, the distance would be 4 meter plus 3 meter plus again 4 meter plus 3 meter. That would be 4, 4, 8, and 6, 14 meters. But displacement would be, because we are joining the initial and the final positions, the initial point is point A and the final position is the point A itself. So displacement is 0 in this case, right? Now let us take one more example before we conclude this. Let us have one more example. Suppose a particle starts from A like this, moves to the point B like this, and then moves to the point C like this in straight lines. This is point A, this is point B, this is point C. This is point C. Say this is 3 meters. Let this be 2 meter, and this is say 2 meters. So as we know, distance is the length of the actual path. So we will take distance as AB plus B, let this be D, BD plus DC, that will be 3 plus 2 plus 2, that will be 7 meter. Now when it comes to displacement, this becomes a little bit difficult here, because we have to join the initial and the final position, and we have to find the length of the line AC. This will give us the displacement. So we have to find out the length of the line AC. For that, we do it like this. We draw a perpendicular from the point A onto the extended line CD. This is the perpendicular line. Now, let this point be O. Now, this is obviously a rectangle ABDO, so this will also be 3 meter. And O and D, then D to C, this total is 5 meter. 3 plus 2, 5 meter. Now, if BD is 2 meter, AO is also 2 meter. Now you can use Pythagoras theorem in this triangle AOC to find the length of the side AC. Displacement is AC, and this is square root of AO square and OC square. AO square plus OC square. This is simply square root of AO square is 2 square plus OC is 5 square. So this will give you square root of 29. Hope this makes distance and displacement very clear. If you have any doubts, you can write in the comment section. Thank you.